So today we're going to discuss a challenge I think we can all relate to in manufacturing: procedure clarity and procedure execution. So how can you ensure procedures are concise and accurate, visualize the procedure steps in the field, and then be able to practice them so you have a standard and correct way to perform them in the field. I'd like to now introduce the speakers today. Francis Montemuro, Director of Operations here at Vuvio. He's got over 30 years of manufacturing experience in many leadership roles, including plant manager at multiple sites in both batch and continuous processes. And then myself, Christian McDermott, the North American coordinator. My background was more on the EPC side before joining Vuvio, where I've been for a number of years, and this is now where my focus is. So moving on, there have been many studies done about the causes of abnormal events. Generally, there's always humans involved, and human error is a major contributor to abnormal events. But let's dig a little bit deeper here. This ASM consortium study concludes that a major root cause of misoperation is related to procedures. You can see that, procedures are either not followed, that they're wrong, or that they're not followed correctly. And we at Vuvio believe this conclusion is fairly valid because our own analysis of procedures shows that they are often full of ambiguities. So moving on to the next slide, we can see that a lot of incident investigations often cite failure to follow procedure as the root cause. However, we think that procedure clarity is more at fault. And the challenge is really about knowing how to execute a procedure as it was intended to be performed. So when you combine expertise leaving the plants through retirements or employee turnover, and then having generic procedures with ambiguous steps, it becomes quite the challenge. So Fran's going to dig a little bit deeper here, but I'm just going to open it up for one more poll here. So what methods does your organization have in place to ensure procedures are understood by the operators? I'll give you guys a few seconds before passing it on to Fran. And here are the results. So it seems procedures are reviewed and updated by technical and operations as being the predominant answer here. So moving on to Fran. Fran? And you're on mute.
Okay, Christian, thank you. So let's talk about procedure clarity for an operator. For an operator, our studies have shown that they need clear and concise actions, and we'll talk about that. And once they have clear and concise actions, they need to be able to visualize performing that procedure line or that action step in the field. And then lastly, they need to be able to practice that procedure either through simulation or in the field. So let's talk about clarity and what our analysis has determined. So we randomly selected 300 procedures over a variety of customer projects that we've implemented. And of the ones we've selected, the majority were startup and shutdown procedures, including equipment swaps. And 90% of those SOPs or procedures that we selected contained ambiguities and generalizations. And I'm going to show you what we mean by that. But there are three reasons that we determine for suboptimal procedure clarity. The first, and we find this in most of our customers, most of our projects, is procedure does not reflect operator practice. All too often at our customers, when we have our engineers walk the procedure with the customer's subject matter expert, we find that within the organization, the practice is not consistent with procedure, and in some cases, there's shift-to-shift variation on how that procedure is executed. So that's the first reason why we find suboptimal procedure clarity. The second one, and we've talked about, is the ambiguities and generalizations that are written into procedures. And I have a couple examples to show and highlight these generalizations. And the last one is inexperience, lack of practice. A lot of operators qualifying a job, and there's been studies done by McKinsey's and others that show that only 40% of the procedure is actually learned and practiced by the operator when they qualify and sign off on a job. And that's mainly due to the operation having to run, the unit having to run, produce product, and it cannot afford to have the startup and shutdown procedures executed because the unit is running. So, Christian, you want to launch the third polling question? So here, what means are in place to ensure practice is consistent with procedure at your sites? We'll leave it open for a few seconds for you to answer. Okay, Christian, let me look at the results. So again, it looks like a three-way split on how the different sites ensure practice is consistent. And we see this across our customers. There's no one good way to ensure that the practice and procedures are aligned, and it does vary by customer. So let me show you some examples of the generalizations that exist at our customers. First example, what I'm going to show on the left-hand side is the single procedure line that is in a customer's procedure. This was in a refinery, and the procedure line said, open the non-instrumented fuel gas cock valves and air dampers, and that was it. And the operator had to know where all those valves and dampers were. When we detailed this single procedure line into actionable steps, it ended up being 10 actions. One for the 5 air dampers and 5 for the 5 fuel gas valves. So again, the clear actionable steps that the operator can then go execute. Another example from a customer was a single procedure line that said manually flush all CTOs, top bottom flushers, etc. And highlighted in green was a caution that was in that procedure that failure to properly flush all the CTOs could or may result in reactor poisoning event. But it did not detail the actionable steps the operator had to perform. When our engineers walked that procedure with the SME in the field, we detailed 53 actions that the operator had to perform to successfully meet this single procedure line to manually flush all the CTOs, and had the operator interacting with 15 different valves. So again, the generalizations that exist in our procedures challenge our operators to clearly understand what needs to happen in the field. So why is this important? Well, procedure clarity results in understanding, and an understanding for an operator results in competency. So this chart on the y-axis is a measure of operator competency, and on the x-axis is time. The gray arrow is what we find in most of our customers when we show up. That's their traditional way of qualifying an operator in a job. Some level of orientation, reading procedures, and then job shadowing. And the job shadowing is dependent upon the SME transferring that knowledge on how he executes the job versus a procedure. And then a final sign-off, test, board review, etc. With Vuvio, we create the action steps and marry it to a digital replica that affords the operator the ability to practice the simulations 24/7, independent of the availability of the SME or the trainer. And they can practice these simulations, build the visualization of how to execute that procedure in the field. And then once they're comfortable and competent in that procedure, they can take a standardized test to demonstrate their competency. And then when they go to execute in the field, when they practice and refresh and ready to execute, they can take the procedure on a device in the field and execute following the standardized simulation. The results we're seeing across our customers is 30 to 50% productivity gain and qualification time, and then competency gains 100%, because they're able to practice the entire procedure, not only what's available to them because of the unit operating. So with that, I'll turn it over to Christian and let him demo Vuvio.
Okay, thank you, Fran. Okay, I'm sharing my screen. Hopefully, Fran, could you confirm this is being shared?
I can see it, yes.
Excellent. So Fran mentioned a few things that I now want to take the opportunity to explain and show you what that means, including digital replicas and simulators. So let's look at how simulating your procedures can really drive that clarity that Fran has been talking about. And remember, it was in 3 ways. It was having clear and concise actions, the ability to visualize your procedure steps, linked to the equipment in the field, and then also to be able to practice them. So everything I'm showing you right now is accessible on a computer or any device with a web browser. So that's an important piece here, is that it's accessible to all operators. On the screen, we have a simulator. So let me explain where my mouse is waving around. So this is the replica, the digital replica. So this is the real view of your plant, where you have your equipment. You can walk around and interact and perform the procedure you see here as it is intended. Below that, we have a map, so you can always view where you are and where you need to get to, if it's on multiple levels or across the, you've got to go from one side of the plant to the other. On the left, where I'm waving around now, this is the procedure. This is the procedure document that we do not edit. So this would be as the operators would maybe print out or view on their devices. Above that, we have an action checklist, and this is what Fran was alluding to before. And so let me show you this example. So the procedure step says open the condenser water box vent valves. It does specify the front and rear, but it doesn't specify how many there are or what they're really called, if there's an ID or anything like that. So in this action checklist, you'll see that there are 4 valves. They do have an ID, and there is a sequence to opening them. So let me do the first one here. So I have to physically click on the valve, and this is me controlling it. So you physically have to interact with the equipment and execute it. And you'll see that this simulator now jumps to the next action step in the procedure. It's still the same step in the procedure, but we're doing a new action step up here because there's 4 actions in this step. So it's like a virtual SME, almost a virtual subject matter expert, walking you through the procedure from step to step. So that action checklist really provides an extra level of clarity. And then the replica, another level of clarity, because it's linked to the actual equipment in the field. So in this example, it's another drain valve. And the fact that you have to physically interact with the equipment on your screen, whether it's a control panel or a valve, or maybe it's using hoses to flush out a system, that is all possible. So you're really learning by doing, thanks to having a simulated procedure. I'd like to point out this, the knowledge snippets. So these are key from a knowledge transfer point of view as well, and also help drive clarity, because you're able to embed pieces of knowledge and link them to specific actions in your procedure. In this case, it's just a piece of text telling me why this valve is always left open. But it could be a video. It could actually be a video of how to perform something, or maybe the reaction to expect, vibration, noise. Those you can embed here in the knowledge snippets. So when you learn this procedure, you're absorbing all of that relevant information in the right place at the right time. So it helps drive that knowledge capture and transfer within the plant. So everything I've just shown you is again, it's like a virtual SME. You can practice it 24/7 thanks to having an on-demand simulator. You don't have to rely on anyone else. You don't have to rely on a person to take you into the field to show you something. You can be proactive and learn it here. But what about, so everything I've been showing you is about building competency and having that procedure clarity. But what about being able to test competency as well? And this is key. So I'd like to show this. So this is a test. It's the same procedure that I was just walking through. But here I'm on my own. So in the replica, you'll see that I can walk around unassisted. I could interact with any piece of equipment that I wanted. But let me do the first step correctly here. So I'm going to walk down to this drain valve, and I remember it is up here. And again, you can do it without labels, but you could also turn the labels on to give you that extra bit of help as well. So I can clearly see this is the drain valve 995, confirm. And you'll see on the left, I get immediate feedback saying I got it right in this report. So what if I make a mistake? So again, the simulator allows you to make mistakes and learn from them and then retry them. So again, driving that clarity. So let me show you here. I've just made a mistake. I interacted with the wrong valve. Maybe you do something out of sequence. Maybe you've forgotten a step. But here it will log everything you've done, and it will give you the opportunity to review and try again, because it's a simulator. So let me try again. It will reset to where we were, and I'm going to check that this correct valve is open. Yes. And confirm, and you'll see I got it right after 2 attempts in this report down here. So that's again, the beauty and the power of simulation is you can have this way of measuring the knowledge of entire procedures before you go out and do them. And you have these detailed logs here, which show where operators are maybe having trouble or frequently missed steps. And this data allows you to improve the procedure. Maybe there's improvements to be made, or maybe on the training side as well. So very powerful. So everything I've shown you is about building and measuring competency, but what about having clarity when you're in the field? So let me show you this. This is a visual aid, which you would have on a mobile device in the field. A very simple interface, but you have your clear and concise action step at the top here. And then the pictures drawn from the simulator. So you can toggle between that detailed view of that valve, or if it's a piece of another piece of equipment or a certain button on a control panel, you can have that detailed view as well as the view from the pathway where to find that. So once you've done that step in real life, you click that green button and it will move you to the next step. And those knowledge snippets, that knowledge capture tool is available in the field as well. So that can, again, provide extra clarity and confidence to operators in doing the right thing. You can also add notes as well. Which you can log at any time. And all of this information is stored and captured in the cloud in the form of a log, again, which you can review at any time. Each step when it was executed, the notes you've taken, so that is all available. But that hopefully has shown how both before you go in the field and when you're in the field, you can have clear and concise actions, and that ability to visualize what each step in the procedure's supposed to be, and then to practice it. So with that, I'm going to pass it back to Fran, who's going to continue.
Okay, thank you, Christian. Let me go full screen here. Okay, so as Christian talked about, we talked about the line walk that our engineers do with the subject matter expert and the ability to build that procedure clarity with clear, actionable steps that we then marry to the replica. What this chart shows is some of the results from projects. The y-axis on the left is the number of procedure steps or procedure lines, and then across the bottom are sets of bars. The blue bars are the number of procedure lines prior to us walking the procedure in the field. So that's the customer procedure as written. The orange bar are the number of action steps, the clear, concise actions that the operator has to perform. And that is the action checklist that is created after our engineers walk the procedure with the SME. So if we take this first set of bars, the number of procedure lines was 25. And then we went and walked that procedure in the field with the SME and come up with 117 actions that the operator had to perform. So back to the demo that you saw from Christian, that would be the upper left-hand corner, the 117 actions that the operator performed. And you can see over all our projects, the average in industry is about a factor of about 2.4 number of actions to procedure lines that we encounter across our projects. As with all our projects, we get operator feedback. We value their input, and over the 3 years that we've been getting their feedback, we've had the operators all strongly agree that procedure simulators make it easier for them to learn and understand their procedures versus their traditional methods. The simulators provide a level of clarity in their jobs that they have not had before. And then lastly, they felt that it would increase their ability to comply with the operating procedures, mainly because the simulations are accurate and action-based. They know exactly what they need to do to perform the procedure correctly. It affords them a level of visual clarity so they can visually understand what they need to do before they even get to the field. And then procedures in practice they're aligned and standardized. We don't have certain shifts performing the procedure one way or certain individuals performing it one way versus another. So again, everyone is standardized. With that, maybe we can, before I jump into some of the case studies, why don't we see if there's any questions?
So we do have a couple of questions here, Fran. Let's okay, so is there a way to put a note in the simulation test that alerts what could go wrong if the steps are performed incorrectly or out of order?
Yeah, so we could, I mean, I'll start that, Chris, and then you can add anything. But we have the knowledge snippets that we could add into whatever procedure step throughout the simulation to detail what would go wrong if they opened this valve, didn't open the valve, left something isolated. So yes, we can capture the different scenarios and either simulate the scenario or capture the what ifs in the knowledge snippets.
Okay, we have another question here. What is a typical time frame required for developing such a program for procedures? It looks to me that a lot of engineering is involved.
So yeah, so again, I'll take that one. It doesn't require a lot of engineering. We need the customer's procedures, and we will review those procedures several weeks prior to showing up on site. And it's very resource light. We only need a customer resource, probably the subject matter expert, for probably 5 days over the course of the project, outward 7 days. We'll be on site for 3 to 5 days, walking the procedures with the SME. And then we go away and we'll have a couple check-ins during the production timeline. And the production time is typically 14 weeks. We'll check in with that SME twice during the production timeline just to confirm data accuracy. We create the action checklist. We'll want the SME to confirm the action checklist meets their needs. And then we'll deliver the finished product in about 14 weeks. So resource light, does not require engineering. We work in concert with the plant site and the SME with the existing procedures. And the end product is a standardized procedure for the organization to follow.
Yeah, there was another question that was related to resources required, to go through the procedures and then to build everything we've just seen. But you kind of touched on that, right, Fran? I mean,
yes, absolutely.
All that's required from a plant is to provide one SME, or the SME who's the most knowledgeable about those procedures, and we walk through the procedures. And typically, on projects, it could be 3 to 5 days of their time, and that's it.
Yeah, Chris,
yeah,
let me add that we have some customers that say they need to get their procedures in a good place before we do a project, and that's not necessary. We do a full-blown procedure walkthrough, and as long as the customer has a subject matter expert that they're willing to allow them to walk with us for those 3 to 5 days, the end result will be a very detailed, up-to-date procedure that we will then have the customer walk through their MOC process to ensure it's all approved. And once it's approved, we'll take it to production and then have the simulations built.
So I've got a couple of questions which are sort of related. One is, what if a new procedure is to be developed? Does every time a new project, is a new project required every time a new procedure is developed? And then the other question that's related is it possible to make changes once the procedure is completed? I can give a first bash at this. So new procedures, yes, we send someone to the site to capture all of that and walk it through with the SME. But there are cases where we've actually, we already have that digital replica created. If you remember in everything I showed you, that's the ability to walk through the real view plant. So if all of those pictures exist, if you want to add new procedures within that environment, we don't really need to send anyone to the site. So you just send us the procedure and we'll make it happen. In terms of updating existing procedures, maybe you have a new version, you've created a new step, you've removed a step, you've changed the wording. Customers can make some of those changes themselves with an update tool, or again, we provide that service as well. Most customers actually prefer to give it to us, and we'll make those updates for them. Anything to add to that, Fran?
Yeah, I would just add, during the pandemic, we've had many customers take pictures in the field of the new components. If we've already had a simulator created in that unit or that process area, and they wanted to add procedures to it, they would take pictures of the components with the assistance of our engineers virtually. And then we can incorporate those new procedures into their existing replica. So it just depends on the number of components to be added. But we have had customers add procedures by just going out and using their cell phone or some digital camera, taking the pictures and sending them to us.
And we can, if anyone has specific questions about the actual process or technology, we can certainly follow up with them and even provide some more material for that. I've got a question here about, it looks like timeline, 14 weeks, as you said, for a single procedure. What if we have a lot of procedures to work with? Do you have any margins to optimize the overall time required per procedure? So I think, Fran, the 14 weeks, that was a number that Fran stated, which is typical of a project, but that could be 20 procedures or 30 procedures or 50 procedures. So that's not just for one procedure. And as you say, the more procedures we do, the less time and effort it is per procedure. So absolutely, there's economies of scale as you do more. But that 14 weeks was for, we're talking 20, 30, 40, 50 procedures.
It's for a batch, not for one.
Okay, so we got some more questions coming in. Okay, so does taking the procedure on a tablet like this in the field add more time to operations versus recording that items have been completed on paper?
I mean, yeah, based on my experience in manufacturing, it's indifferent. It's the benefit of having it on a tablet in the field is it's something that's saved and you can easily go back and review. You can look at the data analytics, so it does not result in more time. It's an operator recording what they did, whether they open, close the valve. As Christian showed, the field execution tool, once the operator completes that step, it's just he or she clicking the green check mark saying it's complete. So it's probably less time than them having to take the written document out there and follow in the written document. With the field execution tool, you eliminate any chance of error because they can visually see what valve they need to go and actuate, or what component they actually need to go and actuate. So it eliminates any ambiguity on whether they're on the right component before they go and actuate that component.
Okay, I've got one more question. What is the approximate, or a couple more questions, what is the approximate cost per procedure? Shall I take that
Sure.
one, Fran?
Go ahead.
So that, I mean, to give you accurate pricing per procedure, we typically look at the procedures, because a procedure could be 2 pages or it could be 50 pages long. So there is no cost per procedure that you can apply to everything, but it's, you know, incredibly competitive pricing because of the technology behind it. Again, we're dealing with normal photographs taken with a normal camera, and we capture all of that and build these replicas by walking through the procedure with the SMEs. So it's a very efficient process. And if anyone has, you know, who works for a plant, if they want to engage with us and get some accurate pricing, we can definitely do that.
Christian, maybe talk about updating and how those pictures are updated or procedures are updated.
Updating, yeah. So I think you've touched on it before. So procedures, customers get an update tool where they can import new procedure versions and make changes themselves. If there are any pictures required, you know, we can either send someone in, or someone can take those pictures on site with even sometimes a cell phone. We've had, you know, valve picture updates or control panel updates taken with cell phones from operators. So we don't need to visit the site. We've got customers all over, you know, the US and Canada. So, you know, sometimes it's more efficient just to get the pictures sent to us. I've got another question here. Is the product also suitable for maintenance procedures in addition to operations procedures? Fran?
Yeah, yes, absolutely. We have several customers that are using it for in their turnarounds to help several different phases of the turnaround. Initially for the clearing and isolation. So a lot of lockouts, confined space, using Vuvio to ensure lockouts, confined space, etc., are done accurately, and turnover to maintenance is done efficiently and effectively. Customers using it to show how to, whether it's tear down, put back together equipment. So yes, we are also in the maintenance space as well when it comes to disassembly, assembly of critical compressors, turbines, what have you. So yes, definitely suitable for Vuvio.
So I think maybe Fran will pause the questions for now, and we can move on through your case studies.
Okay.
There was one polling question which we wanted to ask before we move on.
Okay.
So what are the biggest challenges you face today in terms of procedures and training operators on them? I'll give everyone a few seconds to get their answers in. Just a couple more seconds, and then
Interesting.
I know there's a lot to read in this poll, so okay, I'll end it here. Share the results.
Yeah, quite a spread.
Quite a spread, yeah.
Okay, so Christian mentioned, let me share some case studies, just a few. The first one's a refinery. And in this refinery, their challenge was eliminating loss of containment. They were having issues with RQs and regulatory fines associated with the releases. And what we found when we went in there with our engineers to walk these procedures was, as I mentioned, that the generalizations that were in these procedures, there was not a clear definition of all the valves that needed to be closed, isolated prior to equipment startup. And then the other benefit coming out of this project that Vuvio brought to light was, once we defined those clear action steps and the operator could practice prior to execution, was the field execution tool. The customer was able to give their operators the ability to go out in the field using tablets to ensure that they touched and closed and isolated every component needed to avoid any future loss of containment. So that's a refinery. Next one is in a petrochemicals plant. Challenge this plant was having was significant yield loss, process startup losses, low yields coming out of a startup. And again, these trace back to procedure clarity issues, but also shift to shift variation in executing the procedure. So again, we walked that procedure with their SME, detailed actions required by the operator, afforded the shift teams the ability to practice and refresh prior to execution, and then go into the field using the field execution tool to perform their startups. Significant drop off in time to first quality, which resulted in a significant reduction in yield losses. So good story there. And lastly is in industrial gases. This was an industrial gas plant that was in support of a very large refinery on the Gulf Coast. So in addition to turnover challenges they were having from a procedure clarity standpoint, they were experiencing issues related to unplanned boiler feed water pump failures. And these were occurring during changeover startups of the boiler feed water pumps. So we got in there, we detailed the actions required for the operator to complete that smooth transition, smooth startup. The operators were then required to practice these procedures prior to any startup of the boiler feed water pump. And this practice, this refresh prior to execution, afforded the operators the ability to then get out there and successfully start up those boiler feed water pumps without incurring the unplanned downtime. So again, you can see the different benefits on the right-hand side. So summarize what we call delivering procedure clarity using Vuvio. We start with a line walk. The line walk is the result, or is the process of our engineer being on site with a subject matter expert and walking the procedures. We address any gaps within the procedures. We address practice not consistent with procedure, and we detail those in our action checklist. And that's the next phase of the clarity, is defining clear action checklists. Once those clear action checklists are defined, we marry that to the digital replica that affords the operator the ability to visualize how they will perform that procedure step, that action in the field. And then we move to measure and refresh competency. The operator can practice right before, the day before, a couple of shifts before them executing in the field, the startup shutdown of equipment, swaps, etc. And they can measure, or they can practice as often as they want. And then as part of qualification process, they have the ability to test and demonstrate competency on that procedure. And then lastly, to ensure accurate execution, is the field execution tool, having it available to them on a tablet in the field, where they can ensure that where they are, what component they're actually going to open, close, etc., is the correct one in the field. So we define that cycle as procedure clarity, the ability for that operator to visualize the action steps and then practice those action steps to ensure accurate execution. Christian, why don't you open up our last polling question? So what do you feel is your site's biggest barrier to implementing enhanced operator training and competency tools? Okay. Good. And share the results, a combination of other priorities and lack of resources and cost cutting. So again, we hear that across the industry as well. Christian, any more questions?
Yeah, we've got a couple coming in. So do we need to develop work instructions along with the procedures, or can we incorporate details in the procedures?
Yeah, there's no need to create anything additional with your procedures. We base the beginning of the project with the frame of the procedure that exists, and then a subject matter expert that takes our engineers around. So whatever exists from a procedure standpoint and the ability for our engineers to walk with the SME, we can create the Vuvio content.
Okay, one last question here. How do you incorporate systems response against different operator actions, right and wrong? We want to train our operators on identifying such responses as well. Do you want to say that, Fran, or do you want me to repeat the question?
Yeah, repeat that again.
How do you incorporate systems response against different operator actions?
Yeah, so it sounds like a dynamic simulator.
Right.
Yeah, so we're not a dynamic simulator. We're going to simulate the procedures as written. We do have several procedures that we've simulated that have if-then statements in them that we can simulate as well. But it's not dynamic in the sense that a certain action will cause this response, and our simulator will know what that response is. We need the SME's input, and then we can simulate the correct response.
Yeah. Well, I think that's pretty much it. So again, if anyone has any other questions, we're always available. I believe our contact information is right on the screen here. Don't forget to follow Vuvio on LinkedIn. Here you'll find other events that we're hosting or involved in. And again, we're always available. If you work at a plant and you're interested in us giving a talk with you guys directly and looking at your own situation and needs and procedures, please get in touch. We're always available.